Hello everyone, good morning, dear authors and invited guests. Welcome to Technical Session 4C. Myself, Karthik Bharadwaj, and this session will be moderated by me. On behalf of Global Knowledge Research Foundation and GR Solistic LLP, it's my pleasure to welcome you all to the 8th World Conference on Smart Trends in System, Security and Sustainability, World S4 2024, London, UK. The 8th edition of the conference is being organized in a hybrid mode. The physical event was organized yesterday in London, UK, and the virtual event is being held through Zoom from 24 to 26 July 2024. I hope you will enjoy the knowledgeable and interactive session throughout the day. In this session, we have 6 presentations. Each presenter will be given 12 minutes for their presentation and 3 minutes for question and answer. On 10 minutes, I will raise a gentle reminder. There is another request to all the participants to stay connected with us till the closing remark. If you have any query or doubt, you can ask it to me in the chat box. Now, I would like to introduce you all with the session chair of the day. So, Dr. Narendra will be joining us as the session chair. Professor Narendra Lode is presently working as professor in the Department of Electrical Engineering of National Institute of Technology, Raipur, Chhattisgarh, India. He has 14 years of rich experience in the academics and research. His main area of research includes medical signal and image processing, biomedical instrumentation, speech signal processing, biometrics, intelligent healthcare brain computer interface, artificial intelligence, and pattern recognition. I request, sir, to please motivate our participants.
Thank you, Harsh, for the introduction. I welcome to the all the participants to this session, and as uh, all these six presentations, I think we have here in this session. I wish all of them a good success for their presentation, and I request now Harsh to start with the presentations, please.
Thank you, sir. Now, I would like to extend my gratitude towards our next session chair, Dr. Milis Kitsing. He is a reactor professor of political economy, Estonia Business School, Estonia. Professor has Professor Kitsing worked as head of research at Foresight Center, a think tank at Estonia Parliament, an advisor of strategy unit of Estonia government office, and head of economics. Analysis at Estonia Ministry of Economics Affairs and Communication. He also served as the president of Estonia Economic Association. Its currently research interests focus on political economy of digital platform and ecosystem. Sir, please motivate our participants.
Thanks very much for the introduction. And I also wish you good luck with your presentations. And I will try to give as much feedback as I can throughout this session. Probably the easiest way would be through the chat because we have very limited time for questions and answers. So it's a pleasure to meet you virtually. And let's start with the session. Thank you.
Thank you, sir. Now we are starting with the first presentation. For the first presentation, I would like to call Shintaro for the paper title, Comparative Analysis of Grade Distributions in Team Taught Introductory Data Science Course for first year students. Presenter, you can proceed with your presentation.
Good morning, everyone. Today, I'll be presenting our research on comparative analysis of grade distribution in team-taught introductory data science courses for first-year students. So this is a case study at Hokuriku University. This study examined the challenges and implications of maintaining fair evaluation in multi-instructor or multiple classes of data science courses. So here's an overview of what I'll cover today. So in recent years, mathematical and data science education has gained significant importance in Japanese higher education. This trend is driven by social changes such as the concept of Society 5.0 and digital transformation. As a result, many universities are integrating these subjects into their general education curricula. However, this integration presents challenges, particularly in delivering uniform content to large number of students and ensuring fair evaluation when multiple instructors are involved. So recognizing in this rapid change of society, Japanese government established its first national AI strategy in 2019. The goal was ambitious: to prepare 50,000 individual college students annually with basic literacy in mathematics, data science, and AI. This wasn't limited to STEM fields. The strategy aimed to reach all university students regardless of their field of study. So our study focused on examining the fairness of evaluation among course instructors in a university-wide information literacy education course at Hokuriku University. We aim to contribute to the improvement of data science education programs in Japanese higher education by analyzing grade distributions and identifying factors that may influence evaluation consistency. So Hokuriku University is a small private institution in Ishikawa Prefecture, Japan. It has approximately 2,400 students across four faculties. In 2020, the university implemented bring your own device, laptop policy, and adapted cloud platform to enhance collaboration and learning. So Hokuriku University launched literacy level data science and AI education program in 2022. So this program consists of two courses. One is information literacy, which is focus of today's study. So the other is introduction to statistics. The program aims to equip students with essential information literacy and data science skills. So this is a picture of the in-class student when students is learning the course materials. So this information literacy course is a compulsory first year subject across all faculties. The course runs for 15 weeks with 90-minute sessions. So classes typically have 40 to 60 students. So the total of about 500 students in each year. So each class assigned an instructor and a senior student assistant. So the course content, each week 90-minute session split into 60 minutes of information literacy content and 30 minutes of data science using Tableau. The course covers basic PC skills, online communication, data analysis, and an introduction to AI. So the Tableau analysis competition was a highlight of the course. So we selected 10 outstanding students from 500 students. So with three students receiving the Tableau Award. So students demonstrated impressive creativity and analytical skills in their visualizations. So we employ a team teaching approach for this course. Instructors come from diverse backgrounds and not necessarily experts in informatics or data science. So to ensure consistency, we hold weekly online meeting where instructors share tips, discuss challenges, and collaborate on upcoming content. So we use Microsoft Teams for this collaboration. So we also provide mentoring for novice instructors to support their professional development. So to maintain fairness, we use standardized grading criteria across all classes. So the evaluation is based on 4 components: mini assignments, task sets based on rubrics, so term paper, and final typing test. So these criteria are designed to assess various aspects of student learning and performance throughout the courses. So our study analyzed grade distributions for the 2022 and 2023 academic years. So we compared pass or fail ratios and grade composition percentages across multiple instructors' classes. So this is a grade chart of grade distribution and pass or fail ratios. So in 2022, we found that pass or fail ratios were nearly identical across classes, so these 4 classes. So the grade composition percentages showed some variations, with one instructor grading more leniently and another more strictly. So orange means C. So however, overall the grade distributions were relatively consistent across classes. But in 2023, we observed significant differences in grade distribution between classes. So there are notable variations in pass rates and grade compositions. Specifically, we found significant difference between 3 pairs of classes. To understand these differences, we examined students' prior academic abilities using placement test scores in Japanese and English. We observed that one class in 2023 showed lower academic abilities compared to others. This finding suggests that difference in student characteristics across classes may contribute to variations in grade distribution, even we use standardized grading criteria. So our findings highlight the importance of real-time information sharing among instructors. We recognize that need for a system to visualize and share weekly assignment submission status. Regular communication and collaboration among teaching staffs are crucial for maintaining consistency. Moreover, considering students' prior academic abilities differences when interpreting grade distribution is essential for fair evaluation. No, sorry. So potential impact of student prior academic abilities on grade distributions. So in conclusion, our study underscores the importance of monitoring and addressing grading differences in team-taught courses. It contributes to developing best practice for designing and delivering university-wide data science courses. So looking ahead, we plan to develop a real-time system for sharing detailed grading values, such as assignment submission. So we will also focus on enhancing mechanisms for instructor collaboration and continue innovating our data science and AI program. So thank you for your attention. So that's all for my presentation. Thank you.
Thank you, sir. I request session chairs if they have any question. Narendra sir, Melis sir.
Oh, yes. Let me ask a question, if you don't mind. Do you use practitioners in your teaching process? I mean, leading practitioners in this area, because I don't know how it is in Japan. I think the same. In Russia, we see considerable progress in medicine information system, which make provide much better medical services, and in government information system, which may provide much better government services. Thank you.
Thank you, sir. Sir, do you have any question? Melis sir, Narendra sir.
I mean, there was a question. I guess now speaker could answer this question that was just asked.
Sorry, did you hear my question? Do you hear me? I
Yeah.
asked, do you use practitioners in your teaching process? I mean, leading practitioners in data science area, especially in information system, because we usually think it's crucial to increase the level of teaching process to invite practitioners, leading practitioners from information system companies. Especially in medical area, in government area, and maybe in financial area too. Thank you. Do you understand my question?
Oh,
The question is, do you invite practitioners, practitioners,
Oh,
people from practice who have leading position in practical companies for information services? Thank
okay,
you.
I understand your questions. So we asked the assistance and help from practitioners from data companies, but instructors are all academic researchers.
Thank you for answer.
Thank you, sir. Any other questions? Okay, so we are moving towards the next presentation. For the next presentation, sir, kindly remove your screen. Thank you. For the next presentation, I would like to call Pavel Zukov for the paper title Effective Growth of Money and in Russia and US, Effective Cryptocurrency. Presenter, you may proceed with your presentation.
Thank you very much. Can I share with my presentation? I mean,
Yes,
can I
sir, you
share?
can
Oh,
share your presentation.
Okay, I do it. I'll do it now. Yes. Do you see my presentation?
Yes, sir, it is visible to us.
Yes. I'm not sure that all effects of the presentation will be actually correctly reflected. Oh, it works. Okay, so the theme of my presentation is scientific. It's scientific to some extent, frankly. It is not, educational. It's rather scientific. In the monetary science, the science of money, and how money supply affects the level of inflation. And but it is very practically oriented. It is not very theoretical. So you see the name of presentation. I will try to make it shorter as possible. Thank you. What is known? What is the concept of the efficient money supply? It's my concept, first of all. That is not somebody else's concept. I started from classical identity exchange. It is well known. Identity, you may find it in any university textbook, but also in any scientific monograph, even the modern one. This leads, probably you know this price level is equal to money supply multiplied to velocity of money circulation and divided to yield like GDP. And this leads to the concept of effective money supply, as proposed by me. This is money supply, exactly M2 growth, adjusted with the correction for real GDP growth and changes in the velocity of money circulation, directly from this identity. However, the identity is very rigorous, but the results will be not that rigorous because all of these indicators are measured by its own way. Theoretically, this indicator should be exactly equal to the GDP deflator, but it is not in practice. And the GDP deflator should be equal to inflation, but it is not in practice because some reasons we may discuss later. What is the use of this concept? Why it is useful? First, you may consider it as just decomposition. If you're familiar with DuPont formula for corporate finance, it is the composition of the rentability of equity into three components: rentability of sales, turnover of assets, and debt leverage. So it's very similar, but not the same. Not the same, of course, because it's not exact. First factor is M2 growth. Second factor is real GDP growth, and third sector is money velocity. And the third sector, variable is the most mysterious. First, it may be explained. First variable may be explained by monetary policy. Second variable by economic development, but third one involves many other factors, including such mysterious things as expectations, psychology, and of course technology. Money velocity depends on technology very much. Financial technology. Why money supply matter? In the long run, inflation is always and everywhere a monetary phenomenon. It's phrased by Friedman. You may see the book. Hall is editor, but the authors are very famous economists. Some of them are Nobel Prize winners now, but it's a very interesting book. How it is old one, but it is actual for now. And the causation between an increase in the money supply and inflation is obvious from the theory. It has been repeatedly confirmed in practice. This one is mine. Let's start with another example from Russia. We may see that GDP deflator adjusted for GDP growth. Well, if we adjust money supply for GDP growth, it will not be correlated very much with GDP deflator. But if we adjust it with money velocity, it will correlate. However, there will be some points of descriptions. You may see it. You may see the 1, 2, 3, 4, 5, 5th and 6 columns. They are almost coincides, but not exactly. Here's graph where I demonstrate the proximity of GDP deflator and growth of the effective money supply. And then you may see a regression table, which is not much informative, but just for information. Let's say, for example, of USA. In USA, we may see in from the 2000 to 2022 and period, inflation was about average 2.5%. Or it was even lower. At the time of Paul Volcker, it was lower, but Paul Volcker, after Paul Volcker, Fed changed its policy, and particularly they actually use now money supply just as well, information. That's for information, not as the main target. The main target is inflation. They purchase targeting inflation targeting policy as the most of central banks now in the Europe and other countries. Well, but 2022 many countries showed peak of inflation because the extremely high level of budget expenditures, because of COVID pandemic, because budget actually compensate to business and individuals their losses for pandemic control measures. That's evident. I think you understand this. And the average inflation was 8.5 in the Eurozone. And the reason was increase in money supply. For example, in the USA, to growth reached 25.8%, which is very high. And in 2022, a very high level too. Totally, it was $6.23 trillion. For comparison, budget deficit was about the same, by 5.9. But as a result of comprehensive measure, there was implemented Inflation Reduction Act, special act by Congress. The problem of certain inflation was resolved. First of all, Fed raised rate to 4.5%, and there was substantial reduction of money supply. Well, we may see it in graph. You see, this is a graph. You may see the growth of money supply during pandemic, and then negative supply of money, which is very unusual for United States. Usual level for United States is 5-7%, sometimes even 10% at the time of depression, at the time of a recession. But minus is very unusual. Correlation is very high for United States, and even correlation of deflation and GDP deflation and inflation. But it is, of course, not. It shall not be understood as a year-to-year coincidence. It is not. Just correlation. Correlation is high, but it is measured over a very long time period. The average global inflation rate was 3.2%, and but in developed countries plus China, I think China may be considered as developed country in many ways, it was 2%. And in Brazil and India, it was higher. In many countries, it was higher, actually. In many developing countries, it was higher. Here is table, but I don't think we'd have much time for this table. But just see that average world inflation is 3.6%. In euro area, it's 2.1, and you may see other numbers. In Switzerland, it's very small, it's very low, but I think it is not good for economy, frankly. It is considered that 2% might be like optimal level. Why money supply matter? After Great Depression caused by extensively tight monetary and fiscal policies, the authorities became obvious that in order to achieve financial stability, it is necessary to apply two kinds of measures: fiscal methods, Keynesians, and monetary methods, monetarism. And the main paradigm is the monetary authorities should maintain a stable rate of growth for money supply, allowing neither to high inflation nor deflation. Discussion. Now we go to the section of discussion. The admissibility and possibility effect of cryptocurrency. I will go shortly through the section. Well, what is good and what is wrong in the idea of stable international cryptocurrency, which was advocated and actually by Zuckerberg, and maybe he didn't leave his efforts on this area. It may be used worldwide, it may be good for business, but it may pose a serious threat to ability of central bank to control the money supply. Theoretically, Zuckerberg attempts, Facebook, to create stable cryptocurrency might be successful, but it meet strong resistance from the U.S. Congress, from the U.S. Treasury, from the Ministry of Finance of Europe, and from the European Central Bank as well, and from many other central banks. Why? Just because we may see that it may lead to uncontrolled money supply. But at the same time, central bank introduce their own digital currencies, we see. China, United States, Russia, and many other countries. Why? Probably it is aimed, firstly, to limit the use of other cryptocurrencies, and possibly to limit the use of cashless settlements. Discussion: the admissibility and possible effects of cryptocurrencies. The answer for the question of whether cryptocurrencies may pose a threat to financial stability depends mainly on whether they will add money supply. Then, whether cryptocurrencies will be used as money for settlements or as quasi-monetary investment assets, even if unquestionable and unstable. For example, M3 includes a lot of quasi-monetary aggregates, and for the same reason, another quasi-monetary assets may be considered. So, the ban on use of cryptocurrencies payments for the supply of goods is a necessary and sufficient condition for the financial safety of these cryptocurrencies. As cryptocurrencies will not increase the money supply, and therefore they not threaten financial stability. Thus, as long as cryptocurrencies remain a risk in financial instruments, they can be threat financial stability. However, theoretically, any cryptocurrencies have a property of classical bubble, since these digital assets do not bring any income, and therefore the price is completely based on the expectations. For example, capitalization of a Bitcoin experienced deep fall and sharp rise, but still it provided a higher income, higher return than market. And it is known that some cryptocurrencies may turn into Ponzi financing, especially as they are created for this purpose. Sorry?
Sorry to interrupt, sir, but you have 1 minute to conclude.
Okay. 1 minute to conclude. Let's go to the the money supply is most adequately reflected by aggregate M2. Depreciation of money in Russia and the United States is well explained by the quantity of money or supply using the concept of efficient money supply. In the US, we see that inflation risks are well managed by the Fed, but there are still concerns about longer terms. For Russia, in the previous time, we saw the high acceleration of the growth rate of money supply, but now central bank changed this policy. I think maybe partially because of my efforts. And it becomes very restrictive. The increase in interest rate of 16%. That efficiently stopped growth of M2, even to negative numbers, but it may hurt investment either. For cryptocurrencies, I will not. That's the literature. That's all. Thank you for attention. And I finish it. Any questions?
Thank you, sir. Thanks, sir. Melissa, Narendra, sir, do you have any question?
Please.
I think we have a very limited time actually for questions. So, why did you focus on Russia and the United States as primary examples? Why not more broadly? So, thank you.
Well, actually, I was not limited by Russia and United States. Actually, I studied a lot more countries, including China, including Argentina, a very substantial example of high inflation, hyperinflation, Turkey, Eurozone, of course, too, but just limited size of paper was not. What is important? United States and Russia have a very different financial system, and American system is much more complicated, much more sophisticated. But in both cases, we see the same law: efficient supply of money, rules, deflator, GDP deflator. That's it. Thank you.
Thank you, sir.
Thank you.
Any more questions? Okay. Now we are moving towards the next presentation. For the next presentation, I would like to call Hibiki Ito for the paper title, Leveraging to Foster Network-Type Thinking in Early Childhood Education Through Picture Books. Presenter, you can proceed with your presentation.
Hi, thank you. So let me share my screen. Oops. So do you see my screen and do you hear me?
Yes, sir, you're audible to us and your screen is visible to us.
Okay, great. So so my name is Hibiki Ito from University of Helsinki, and today I'm presenting the research leveraging informatics to foster network-type thinking in early childhood education through picture books. This work was done in collaboration with Kenya Banaka, Ryosuke Kozaki, Katsuhiko Murakami, Koichi Akashi, Sayaka Matsumoto, and Kunihiko Takamatsu. So here is the outline of the presentation. Starting with introduction, I go through methods, results, and conclusion. So as a background of this research, there is a global trend in education. OECD launched a project called Future Educational Skills 2030. The goal of the project was to develop common language for teaching and learning in 21st century. So the idea is we need new kind of a style of learning and teaching in this modern era. And in the project, systemic thinking, what we call systemic thinking, is emphasized. What is systemic thinking? It's type of thinking where you identify interconnectedness among various concepts across disciplines, which leads to interdisciplinary knowledge. So the idea is you have disciplinary knowledge such as mathematics, language, history, and so on, but you want to build interdisciplinary knowledge by identifying interconnectedness between those disciplinary knowledge. And this can be, sorry, oops, how can I go away? Yes, so this can be described in our simpler model, which we call network type thinking. And in our model, we have pieces of knowledge here as nodes, and learners try to develop network by establishing edges between these nodes using tags or interconnectedness between those nodes. But the question is, how can we develop network type thinking, especially in children? And our focus here in this research is early childhood education, and we also utilize children's picture books for this network type thinking education in early childhood education. There are some prior research. There's a topic modeling research. This is actually done by our group. We did topic modeling on picture books, and we found that there are some topics that connect some of the books to picture books. So there are some cluster of topics, but then there's also a recommender system as a prior research that was based on content-based filtering, which means that recommender system recommends picture books based on the contents of the picture books, for example, text data or visuals of picture books. But the problem is that they are only about pairwise relationships, So it may be that, okay, you can recommend picture books, or this is similar to this one, this is similar to this one, but you may be kind of stuck in a small cluster of picture books or in a small topic. So we want to know, here are our research questions. We want to know how picture books can be mapped to a semantic space. Are they uniformly distributed or are they clusters? And then second, how can picture books connected in the semantic space? Can we identify interconnectedness between picture books in the semantic space? So here are methods we've used. So our approach is essentially what we call edinformatics. The concept is described here. It's the goal of edinformatics is to solve problems raised by educational research, or educational practice with the methods of informatics. So this is our primary approach of this research. And here's what we did. We had text data of 302 Japanese picture books. We did 3 types of encoding on those picture books: bag of words, TF-IDF, and Dr. Beck, which was trained on Japanese Wikipedia entries. And we conducted analysis as follows. We calculated cosine distances of those encodings, embeddings, and then we applied hierarchical clustering. And then we also did cluster reading, which is not informatics method, but it's important to, I will show an example of similar books later. So here are results. Regarding the research question 1, how picture books can be mapped in the semantic space. We define cosine distance here. Here, V and U are vectors and vector embeddings of picture books, different picture books. So the distance falls between 0 and 1. If it's 0, then they're identical. If it's 1, and then the pair is completely different. And here, as you can see, the bag of words embedding produced 2 big clusters, one with close distances and the one with larger distances, which means that similar books are kind of centered around this cluster, and then the other books are kind of distributed around this cluster, which is not really nice in practice. And there is TF-IDF results, and it's also really nice because now the books are quite different from each other, and it may be difficult to find connections. And here is the Dr. Beck results, and it seems plausible because Dr. Beck embedding maps picture books almost uniformly, and most of them are somewhat similar in terms of cosine distance. So it might be easier to find connections or similarities between picture books. So this is nice in practice. So here's an example of pair of picture books that are similar. So this is the most similar pair in terms of Dr. Beck embedding, Two Little Bears, and Town Musicians of Bremen. So these are picture books for children, remember? And I'm not going to provide summaries of those picture books, but here are some examples that I found. I found some example of components that were common in those 2 big picture books. For example, in both books, animal characters embark on a journey, and independence from usual caretakers was one of the key topics of these 2 books. And also on the journey, the animal characters encounter with other animals. And also they both have positive resolutions at the end. So these are very interesting findings that if you use Dr. Beck and find similar books, and then you can find this kind of a bit abstract connections between seemingly different 2 picture books. So yeah, this was the results. So here we go to the conclusion. So we have seen that Dr. Beck plausibly maps picture books to semantic space almost uniformly, and the connections can be established between similar books, which is nice because picture books are potential tools for cultivating network typing network type thinking in children. So we could utilize Dr. and recommend picture books so that children or maybe the early childhood education instructors can provide picture books and try to find connections between those similar books that are mostly uniformly distributed in the semantic space. However, there are limitations in the research, so the future work includes to develop text embedding that reflects language of picture books, because we've trained the model, Dr. model based on the Wikipedia articles, which is not necessarily similar to the language of picture books. And also we should incorporate visuals as a cue to identify connections, because we only consider text data in this research. And most importantly, our future goal is to design curricula to utilize picture books to develop network type thinking in early childhood education. So this is it's about my research. Thank you.
Thank you, sir. I request Melissa and Narendra, sir. Do you have any questions, sir?
Yes, I do. Thank you very much. Very fascinating presentation. I wanted to ask you that in a more general level, that if you use that type of sort of network analysis, can you also somehow point out what type of networks there are in these semantic spaces? For instance, are they more like centralized or decentralized networks, or are some books like in the center of the network? Is it sort of more sort of centralized that one book is in the center and then others are like linked to it? And maybe interesting question would be, maybe it's like way beyond your research, but could you also somehow connect it to the sort of like more social networks, that in what type of social circles, what type of big picture books are more prominent, or is that like way too complicated? But a very fascinating presentation. Thank you.
Thank you very much for your question. And that's a good point. Actually, in the past research, we did network analysis on picture books, but the number of picture books is limited. Oh, well, better the results was that they're still uniformly distributed. There's no like a strong centrality, and which is really nice results in practice. But the number of picture books we analyzed was limited. So it would be interesting to incorporate more and more books to find some trends in the network.
And about social networks, I mean, anything that you could connect it somehow to the social networks, that what kind of books could be in a different social circles or networks or groups more prominent or less, or is that like way beyond what you actually intend to do?
No, that's an interesting topic. I haven't myself thought about that, but that would be definitely interesting thing to do in the future. Yeah, thank you very much.
Thank you. Thanks so much.
I have one question as well. As rightly said by Professor Millis, your concept is entirely based on the pictures, because there is a thought that picture speaks thousands words compared to the text, right? But I have one very important query here, that during the childhood, if you're giving so many picture books to learn the things to the children's, what will happen to their learning about writing and reading? So is it going to affect that thing, those two things?
Yeah, I mean, I'm not. Yeah, thank you very much for your comment. That's an interesting perspective, because we only focused on reading, and we didn't think about writing or any kind of expressing language. But I'm not saying that we're going to force children to read a lot of books to build a network, but the point is, it would be interesting to for children to identify interconnectedness. It's not necessarily
because learning is important, as at the same time the expression is also important, and expression comes from either writing, by writing the things, or maybe you be expressing it by speaking. Speech is important, text is important. So is it going to affect that things? That's what I feel.
I would say yes. You could relate this approach to writing and speaking. Writing is a little bit difficult, maybe for like 5-year-old kids, small kids in Japan, because of the language. We have complicated language system, but definitely speaking, for example, is a nice way of incorporating to our future work of designing curricula using this network type thinking education.
Okay, nice presentation. Thank you so much.
Thank you.
Carl.
Thank you, sir. Thank you, sir. Now we are moving towards the next presentation of the day. For the next presentation, I would like to call Josephine for the paper title Towards the Understanding of Electronic Government and Electronic Governance in Developing Nations. Where are we? Presenter, you can proceed with your presentation.
Good afternoon, all. Let me share my screen.
Good afternoon, ma'am.
So good afternoon, all. I'm Okocha Josephine from the African Center of Technological Enhanced Learning, Nigerian Open University. So my presentation is on towards the understanding of electronic governments and electronic governance in developing nations. Where are we? So these are the outlines. Developing nations in the world today are still suffering from high level of poverty and poor living conditions. And this is as a result of poor implementation of e-governance in most of these countries. We have over 83% of the global population ranked among the developing nations. So a large portion of the population of the world are in the developing nations, where e-governance is hardly been implemented properly. So this research is investigating e-governance landscape in these developing countries, trying to analyze the deployment of digital solutions, which will be able to enhance public sector efficiency and transparency. The implementation of e-government services in these developing nations is mostly hampered by social and political obstacles, which has caused the weakness in governance and which has hampered development in these developing nations. So this is the major problem in this study that we are looking at. The research aim and objective. The aim of this research is to investigate or understudy the e-governance landscape in developing nations, trying to analyze the digital solutions that these nations are already implementing, and try to underscore the importance of these electronic government services in these developing nations. The research is also looking at how improved service delivery can drive sustainable development and help attain United Nations SDG goals. One of the objectives of this research is to find out the current state of e-government development and implementation in these developing nations. One other objective is to look at the challenges, the limitations, and the opportunities facing e-governance initiatives in these nations. The limitation of the study. The study actually focuses on quantitative study rather than qualitative or mixed. So this will affect the finding of the study because other studies outside these descriptions were excluded from the analysis. Also, the study retrieved from the database were restricted to search terms used. The justification of the study. This study So the study actually looked at 10 developing nations, how their e-governance landscape is being worked on, and what the state actually is in those 10 nations. The literature review. United Nations survey report showed that countries like Haiti, Niger, Chad, Eritrea, Somalia, and South Sudan, they all have very low e-government development index with as low as 0.09, while that of developing nations is as high as 0.09. So there's a large disparity between e-governance practice or implementation in developing nations and that of the developed nations. Also, there's a low score of 0.03 for Libya in their e-development index compared to that of Denmark and that of US, which is as high as 0.95. So leveraging on e-governance by these developing nations can lead to proper development in all sectors. So what are the research questions for this study? So the research tends to answer these questions. One, what is the current state of e-government development and implementation in developing nations? Number two, what are the challenges, the opportunities, and the limitations facing e-government initiatives in these nations? We adopted the literature review method. We got a total of 76 papers from the Scopus database. So we analyzed them using some inclusion criteria to select about 20 papers, which was used for this analysis. The data we analyzed using a thematic analysis approach, which involves identifying patterns and themes in the data. From our findings, we discovered that the 10 developing nations we looked at, which were Nigeria, India, Bangladesh, Iraq, Philippines, Libya, Nepal, Peru, Pakistan, and Rwanda, we realized that there was a drop between 2020 and 2022 in their e-participation index, where we have countries like Libya having very low e-participation index and very low telecommunication infrastructure. Also, countries like India had a drop in their e-participation index from 0.85 to 0.59, which is a decline in their e-participation. For most of the countries, a slight increase like Nigeria, Iraq, and Nepal, they had a slight increase in online service index and telecommunication infrastructure. What's the state of e-governance in these developing nations? So we analyzed the state of governance under 3 criteria: the existence of an e-government plan, the existence of digital ID and authentication for online, and also the existence of an online platform for public procurement. So we realized that countries like Nigeria, they had no existence of digital ID or authentication for online service. Iraq don't have there's no existence of an e-government plan. They lack also the existence of digital ID and authentication for online service. They also lack the existence of an online platform for public procurement. So we also tried to compare the e-government development index for 2022 with that of developing nations and developed nations. The findings revealed that there is still a large disparity between the level of e-governance with developing and developed nations. From the findings, we realized that countries like India had 0.59, Bangladesh 0.56, 0.65. When we compared those values with what we have in the developed nations like Denmark, Finland, New Zealand, Australia, and United States, you see that there is a large disparity. All the developed nations had their EDGI above 0.9, while for the developing nations, they have theirs below 0.6. In conclusion, the government of these emerging economies should see e-governance as a necessary tool to drive development. So if there's going to be any form of meaningful development and to reduce the level of poverty in these developing nations, then the issue of e-governance should be looked into by governments of these developed nations. And also, future research can also be carried out on how to move countries from low EDGI to medium, and countries that are in the medium EDGI to high. These are my references. Thank you for listening.
Thank you. I request Melissa and another sir. Do you have any questions, sir?
May I ask a question, please? My question is, actually, you have spoke to us about government informational system, about electronic government, about governmental services. But what about medical services? Do you think it is important to develop informational system in medicine? Because from my understanding, it is a very important point to increase medical services. Thank you. Do you understand my question? Do you understand my question?
Yeah, I understand your question, sir.
Thank you.
Yes, I think information systems for medical services is also a key point. It's just that this research was just looking strictly at what are the e-government services they have in place for now. So, but in the long run, the e-government services should also encompass medical services. Because when we're talking about e-government services, we're saying how can government provide basic amenities to the people using electronic governance or using ICT. So developing information systems for medical services is also key in that aspect as well. So I would say that the governments of developing nations should also key into that area as it's part of e-governance as well. Thank you.
Thank you very much. Still, I think I would recommend you to consider the medical area for information system because I think it might be in great importance for all the world and particularly for developing countries. Thank you.
Thank you, sir.
Just a very quick comment that I basically think the developing countries are quite diverse. So there are very different types of developing countries, and in some of the low-income countries, actually, you have problems that go way beyond anything that those e-government indexes measure. So I actually posted one suggestion to take a look in the chat. For instance, there is a very nice paper in telecommunications policy, which kind of demonstrates how access to electricity could be a problem for use of the ICTs, and this is obviously like issue in many of the low-income countries. So I think it's a little bit like difficult to consider everything that is going on in the developing countries. Maybe there could be like a bit more focus on what type of countries you're looking at. And in that sense, I wasn't also sure why you had selected those particular countries that you had. And in general, my suggestion is to go beyond this UN e-government index. I mean, I've actually done a lot of research in this area, including I've also contributed those UN government indexes myself. So there are certain like limitations what they actually measure and what the possibilities are. So, but that could be the next step to go beyond and look at more sort of specialized literature that has discussed it. And I just posted like one of those here in the comments. Thank you.
Thank you, sir.
Thank you, sir.
Okay.
Yes, ma'am.
Okay, I wanted to react to his comment. Well, actually, my research looked at those in the medium EDG, medium e-governance development index. So not those that are critically low, because just as you said, those that are in the very low level, like countries like Sudan, Eritrea, so looking push e-governance might be different from the way you're looking at pushing those from the medium to the high. So, and also I did not just use the United Nations reports only. I also looked at some other published articles on e-governance between the year 2020 and 2024. So just as you said, the policies that may be implemented for those very low income countries might slightly be different because their issues are a little much more different than those in the medium. Those in the medium has already gone past some stages. So they just need some more push to get to the high or to get to the stage of developing nation. So in my research, I actually chose those 10. They are under the medium. So their cases is not as critical as those below, the Sudan, the Eritrea, because from those ones, we're looking at access to electricity, access to internet access, what are government policies backing e-governance and the likes. But I think in future research, I'll look at that as well. Thank you.
Sure, but then you could be more specific in your title and the talk, rather than say developing countries, say specifically that certain type of developing countries. I don't know, medium developing countries, or not low income developing countries, or yeah, it could be more specific in this case. Thank you.
Yeah, thank you. Noted.
Thank you, sir and ma'am. Now we are moving to the next presentation. For the next presentation, I would like to call Elov Botar for the paper title, Processing of Uzbek Language Text Using the Skip Gram Method. Presenter, you can proceed with your presentation.
Hello, dear colleagues. I am Shahlo Hamroeva. Botar Elov is also here, but I will present. It's okay?
Yeah, ma'am, it's okay, no problem. You can proceed with the presentation.
Can you see my screen?
Yes, ma'am, your screen is visible to us.
Okay. Today's our research paper is about processing of Uzbek language text using skip gram method.
Sorry to interrupt, ma'am, but some of the context, the screen is not visible.
And now?
No, ma'am.
Can you see?
Can you here?
Can you see my screen?
Yes, ma'am. Your screen is visible to us.
Okay. In introduction, I want to say natural language processing is a field of artificial intelligence that facilitates communication between computer and human. Through an NLP method, it's necessary to express words and phrases in the form of digital vectors to make their processing easier, such a task of modeling natural language. Is called word embedding. Word embedding this is method a way of expressing words numerically, allowing machine learning algorithms to understand words with similar meanings. This method enables the modeling of natural language by identifying the numerical vectors of words using neural networks, probability models, or by reducing dimensions in the joint matrix of words. Word placement is also referred to as distributed semantic models or a vector space model. In the definitions mentioned above, you will come across the semantic word meaning categorizing similar words. For example, fruits such as apples, bananas should be placed close together. The word book would be quite far from these words. In this slide, we want to show the scheme of utilizing the word embedding methods. The word placement method helped in document clustering, text classification, and natural language processing tasks. Below are applications of the word placement method in NLP applications. Similar words used to suggest words similar to a given word in the word placement model. The model also allows for the identification of dissimilar words. Forming a group of interrelated words, the method is used for semantic grouping of similar and dissimilar words. Second, the text classification feature is, we can say, vectors placed in arrays are given to model for text training and prediction. Text-based classifier models cannot be trained in a row, so it's necessary to transform the text into a form that can be learned by machine. Document clustering, the word-to-vec method can be used to classify corpus documents. And in natural language processing, the word placement method can be used to solve NLP tasks such as post-tagging, sentiment analysis, and syntactic analysis. In this paper, we want to discuss the method word-to-vec. As SIBO and skipgram method, the skipgram method processes each word of a sentence in a language corpus and attempts to use the current word to predict its neighbor. In the SIBO method, the current word is predicted using this context. A parameter called window size is used to limit the number of words in each context. Here we can see the process of analyzing the context. Here is some sentences from corpus, from Uzbek language corpus. The numerical vectors used for representing words are called neural word embeddings when they are based on a neural network. The word-to-vec method vectorizes words in a language corpus based on this approach and provides the ability to understand natural language on a computer by performing mathematical operations on the numeral vector corresponding to words. Their semantic proximity can be determined. Words take on a numeral form based on a neural network. The word-to-vec method similar to an autoencoder encodes each word in the corpus into a vector and learns them based on other words that are their neighbors. The learning process is carried out in one of two methods, either using the context to predict the target word as well, or using the word to predict the so-called target context known as skipgram. Because the SIBO method has given more precise results in language datasets. This article examines the application of the skipgram method for processing text in Uzbek language. I want to speak about another method, one-hot encoding model. Based on the information above, it's understandable that the neural network needs to process certain pairs of words from the corpus. To do this, words must be expressed in a mathematical way for the neural network to process these pairs. Using the one-hot encoding method, a dictionary consisting of the words dam oluşkunları hava hararati asta sekin ko'tariladi is formed corresponding to the sentence. The weather temperature gradually rises on weekend. The word havo is represented by the following vector. We can see here. The one-hot encoding model forms a hot vector for a single word in the text corpus. The hot vector is the vector representation of the word, where the vector length depends on the size of dictionary. Skipgram model, a necessary condition for any neural network or any supervised training technique is having labeled training data. If we don't have labeled data, that's words and their corresponding words placements. How can we implement word placement based on neural networks? If the window size is set to 2 in the sentence, dam oluşkunları hava hararati sekin ko'tariladi, and the target word is havo, when its neighboring words will consist of holiday, day, temperature gradually. In the neural network, the input corresponding to the word weather and the target word pairs are the follows. Havo kunları, havo oluş, and others. Here we can see a skipgram model architecture. In this architecture, the number of unique words, and in the text corpus, X input layer, and the number of neurons in the neural network hidden layer, W the weights between the neural networks input and hidden layers, and Y softmax output layer with the probability of each word to vocabulary. There is another skipgram model architecture, entrance layer and exit layer, and between these here is another layer. We have here some mathematic models, and I want to...
You have 2 minutes to conclude.
Okay. In results, I want to say the author applied the skipgram method to text from a 2 billion word Uzbek language corpus and formed the word two-way model. The following image presents a visual representation of the skipgram methods. In a conclusion, I want to say the following can be noted as a conclusion of word-to-word learns word placement. The second, word-to-word analyzes patterns that emerge together in a corpus to identify semantic relationship based on the language corpus. The third, the method uses a neural network through either SIBO and skipgram methods. Features from the methods can be used in various NLP tasks. The word-to-word methods requires a large training corpus for accuracy. The method does not determine the meaning of words. Word-to-vec does not consider word order, and out of vocabulary words are not processed. Thank you for attention.
Melissa, Narinder sir, do you have any question?
Yes, this is natural language processing. It is something a very common field, and many people are working in this particular field. Okay, what contribution that you have in this particular presentation? First is that question. Second question is that uh,
The first question, sorry, first question.
first question is that what is the contribution in this particular paper? Because the methodology looks very similar, it's very familiar, it is already available in the literature. What is your contribution in this presentation? Second thing is that whatever the method that you have applied to the 2 billion word data set of your Uzbekistan language, right? So in that results, how many words has been successfully identified? So have you done any measurement, quantitative measurement, where accuracy maybe has been calculated, and sensitivity, specificity, something, some sort of that study has been conducted by you?
Okay. The first questions, I want to say for the first question, I want to say I am a linguist, and my contributions for this paper is to complete Uzbek language corpus text, and if we speak about the message, how much words. I want to say Uzbek language corpus. In Uzbek language corpus, there are 2 billion words now, and we process 2 billion words with the methods skipgram and SIBO.
Right. I got that point, but what I'm asking you, that have you measured that that detection of the word, whatever the 2 billion words that you have taken, okay, how many of that words has been successfully identified? Successfully identified.
Successful, and I can say it may be over the 90%.
That quantitative measurement should also be included, because when you are applying any automated method, okay, so you have to ensure that that method has been quantitatively measured for its implementation. That is what is suggestion, right? Thank you so much.
Thank you.
Thank you, sir. Melissa, do you have any question?
No, thank you.
Thank you, sir. Now we are moving towards the closing remark. I sincerely thank our authors for their excellent presentation and contribution in this session, and all our participants for being a part of this international conference. I hope this session was informative enough, and we, on behalf of the whole team, thank you for your support during the 8th version and all the previous 7 versions of the conference. We'll be happy to have you in the 9th version in 2025. All the presenters will be getting their digital certificates within 2 working days. Further, all the papers has been already forwarded to Springer for publication. The publication will be live within 6 months. Kindly cooperate with the team of World S4 2024. I also thank our session chair, Dr. Narendra, for chairing the session. This is a token of appreciation from Team World S4 and Global Knowledge Research Foundation and partners. Thank you, sir, for your valuable presence. Kindly address our participants.
Thank you, Karthik. I'm really delighted to mention that we have seen all the six presentations were from the different domains, and we have been catered with a very uh, means with variety of works, and it was quite interesting to hear all those talks. I sincerely wish the luck to all the participants present here, those who have presented their papers in in this session. And I'm really also happy to meet Professor Melis Kitson for the first time on screen. So I am actually, sir, we are co-editing the proceedings of the this World Conference for last 2-3 editions. But I could not meet you personally, so I could see you today, and I'm really happy to see you, sir, and sharing this dais with you. So thank you so much, and that's all from my side.
Thank you, sir. Now, I would love to extend my gratitude towards our next session chair, Dr. Melis Kitsing, for chairing the session. Sir, this is the token of appreciation from Team World S4 and Global Knowledge Research Foundation for chairing the session. Thank you, sir, for your valuable presence. Kindly address our participants.
Yeah, thank you. Thanks very much for this certificate, and also thank you very much, Professor Lande, for your kind words. And it's a pleasure to meet you in person, in virtually here as well. It's also a pleasure to meet everybody who presented. And indeed, we had very diverse presentations, ranging from macroeconomics to ICT in developing countries, and then semantic spaces of the pictures, and so on. So it was quite diverse, and I have to say quite educational for me as well. So I learned a lot from you, and I hope that my comments and questions were helpful to you as well. So thanks again, and congratulations on your presentation and forthcoming publication.
Thank you, sir. Now, I request everyone to turn on their cameras for a quick snapshot of the conference. I request everyone to please turn on their cameras for a quick snapshot of the conference. Thank you, everyone. Stay safe, take care, stay connected. We'll be happy to have you in the 9th version in 2025. Bye-bye. Thank you. Thank you, everyone.
Thank you. Bye-bye.
Thank you, sir.
Thank you, everybody. Thank you very much for the pleasant
Thank you,
discussion.
sir.